Hello, 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 hello. We're gonna study today algebra. Algebra. The basis of algebra. Basic algebra. This is what we're gonna work today. Let me set up everything. I hope that everything is working, that there's no issue with the internet today, like yesterday, that I couldn't work out. Gonna work today. Yeah, it's correct. It seems that everything works. So we're going to start working on exercises of algebra. We're going to see converting phrases into algebraic expressions. We're going to see how to evaluate, how to solve equations, and if we have time, we're going to work a little bit of integers. So we're going to do some exercises about it, and we're gonna start now. So let's see the first question that we're going to work here. The first question we're going to work here says that we need to convert the following phrases into algebraic expressions. And whenever you need to convert phrases into algebraic expressions, you need to identify the operation. So there are keywords that tells you what is the operation that we're going to perform. How did you identify those keywords? So this is something that you must read. For example, here one keyword is product and another keyword is times. These are keywords that tells you that there's an operation there. So anytime you see these keywords, it means that you have operations. Product in this case means times, and times in this case also means times, multiplication. So product multiplication times multiplication. So it means that in this case we need to multiply the product of 3 times a number. So you need to multiply 3 times a number, and so it means multiplication. Hi, hello in the chat. And 65. So this is kind of, I need to multiply 3 times n times 65. That will be kind of our operation. However, remember that in algebra, we put coefficients first. So in this case, we need to multiply 3 times 65. 3 times 65, so I'm going to multiply it here, 3 times 65. 3 times 65 is the same as 180 plus 15, so it's 195. 3 times 65, 195, and we don't put the multiplication sign, we just put n. In algebra, we put the coefficient first. Hello, the chat. We put the coefficient first and then the variable. So the number could be n, or could be f, could be a, could be b, the variable you want. In this case, I'm using n. And this is how you work out this type of situations. Any type of situation, you need to identify the operation involved. For example, here, let's say that I'm here. 6 more than, so this is an operation. And there's another operation here that it says half a number. So identify the operations that are involved. In this case, more than means addition. Hi, Laura. Means addition. So here we have an addition. And half means divided by 2. So I need to divide by 2 something. Okay, so every word that you read, it's going to tell you what is the operation involved. So in this case, we have more than, addition, and half means divided by 2. So just remember that when you say more than or less than, and you're talking about an operation, not the inequality, so the number that goes first in your operation, subtraction or addition, is the number that goes at the end of the sentence. Okay, so in this case, it says 6 more than half a number, so I need to put first half the number and then the 6. Half the number could be written as, let's see that I'm going to tell that the number is a. So half the number could be written as a divided 2 plus, because it says more than, 6. Okay, so this is an option to write this algebraic operation. Maybe you want to write the half first and then a, both are okay, you can put half and then the a. This is how you can work out these type of problems. Now, in the other questions, I'm just going to highlight so you can understand what is the operation we're talking about. In this case, for example, it says the subtraction, and there's another that it says twice the subtraction of h from, when it says from, means that this one goes first. This is the one I'm going to take the subtraction from. So I need to put first twice z and then the h. This is how you can do it. In the case of x less than, so it means subtraction, right? So it means subtraction. So it will be 69 subtracted x, okay? Because it says less than. Just remember that when it says less than, we're talking about this operation. The other keyword that appears here, is the quotient. The quotient means division. So you can divide by numbers so you can get the answer. So you can get the answer by getting the division. And finally here it says product and plus. So product and plus. Give me a minute. Let's see if I can share some link here. There's a problem here. Oh God. Okay, give me a minute. Now let me know if it's correct, if you understand what I'm talking about, if what I'm telling you makes sense for you. The idea is that you identify keywords. The keywords tells you what is the operation we're performing, right? So this is the main idea. If you have the keywords, you can find the key idea. Okay. Now we're going to continue with the next part. The next part it's about the next part that we're going to work on is about work out the value of the expression. Okay, in a minute I'm going to do workout with function machines. Work out the value of each expression. So when you want to work the value of an expression, what you just need to do is just substitute the variable by the number that is given. So in this case, the variable m is 2. In this case, I'm going to replace the variable c by -3. And in this case, that is the example that I'm going to perform, is that you need to replace the variable x for -5 and the variable f by -7. I'm going to put it like bigger so you can see it better. So what I'm going to do is just replace x by -5 and I'm going to replace f, or substitute f by -7. This is the idea of this type of situations in which you need to evaluate. So basically what I need to do is 12. Remember that in algebra, if the variable comes with a coefficient, means that this is a multiplication. So actually here what I'm doing is 12 times -5 minus f, that is -7 minus 7. Okay, so I'm going to perform this operation. Remember that multiplication should go first. So you must do first the multiplication and then the subtraction. So I'm going to multiply 12 times -5. Positive times negative is negative, so this is going to give you -60. And subtracting the negative is the same as adding the opposite, so it means +7. So what I'm going to do is -60 plus 7. Now, remember that if you don't remember how to add integers, you can imagine these numbers on a number line like an arrow. So imagine an arrow that is -60, and for this arrow you're going to put a +7 here. And what we want to know is this answer? How much is this number? Now look at that, this number is negative, right? Because it's going to the left. So it's a negative number. I know that it's a negative number. And as you can see, it's the subtraction of 60 and 7. So this number is the subtraction of 60 and 7. That is 53. So negative 53 is going to be my expression evaluated in x equals negative 5 and f equals negative 7. Negative 7. Okay? So this is how it works. This is how you can work out on these problems. Just substitute the variable, and if you substitute the variable, you can get into your different results. Okay. Let's see more of algebra. We already see how to convert phrases into algebraic language. We already see how to substitute or evaluate an expression. Now we're going to do the next. We're going to see another. That is when you need to simplify an expression. When you need to simplify expressions, you can apply two things. First, collecting like terms. And on the other hand, after collecting like terms, the other option is that you need to simplify parentheses by applying distributive property. So I'm going to show you how to simplify using like terms and how to work out with parentheses. So in this case, for example, this question that is here, I need to identify what are the like terms. So the like terms, for example, is the terms that have the x and the terms that have y. So these are like terms. So I'm going to rearrange them in a way that I can write it, the like terms on the same line. So I'm going to put negative 72x minus 21x plus 16y minus 30y. Remember that the sign corresponds to the term. The whole term includes the sign. You must, if you move the term, you move it with the sign. This is something important. Move it with the sign, because if you don't move it with the sign, you're not applying the operation. This comes from integers. The subtraction is adding the negative. So here what you're doing is adding this negative. That's why you should move both the terms. Now, what I'm going to do is to add the terms that has the x. So this means negative 72 minus 21. So if you imagine again your number line, minus 72 minus 21. So you can see that the answer is going to be all this number that in terms is negative. You see, it's a negative number, and it's going to be the addition of 72 and 21. So basically I just need to add 72 and 21, but it's negative. So this is gonna give me negative 93x. And now I'm going to add the terms that has a y. So I'm going to add here y and y. So I need to add 16y minus 30y. Actually, I forgot here to put that this is x, right? So 16x minus 30y. So I'm going to do it here. 16y minus 30y. Something like this. Okay, now if I imagine my number line, I just need to put here my initial point. Look at that, the answer is going to be a negative number. Okay, and this number must be the subtraction of 30 and 16. Look at, because 16 plus these numbers should give me 30. So to sum up, my answer is going to be minus 14y. This is how you do this type of exercises, in which you collect like terms to simplify the expression. This is like adding apples with apples, pears with pears, centimeters with centimeters, cubes with cubes, that stuff. Okay? Now, on the other side, when you need to simplify a parenthesis, we apply distributive property. So in this case, I just need to apply 5 times 2n, and I need to apply 5 times 6m. So this is 5 times 2n minus, keep the minus, 5 times 6m. So I'm just going to apply distributive property. So I'm going to multiply 5 times 2 is going to give me 10n minus 6 times 5, 30m. Remember that in algebra, we put the coefficient first. We don't put the multiplication sign and then the variable. This is important when you communicate information in algebra. Do not put the multiplication sign and put first the coefficient. Include the coefficient. Okay? Now we're going to work on function machines. Constructing the function machine for the equations so you can solve it. Function machines are a good idea when you're learning how to solve equations because it's going to give you a main whole of how you can use the properties of equalities to solve an equation. So this is why you assemble the function machine. You assemble the function machine in a way that you can solve any equation. So we're going to see how to assemble the function machine. I'm going to do it just for this exercise that is here. It says negative 8y plus 12y plus 12 equals 20. And what I need to do now is to identify that here in this case, I have y, but I have an expression that is added. So first thing I'm going to do is to simplify my expression so I can construct the function machine. In principle, function machines can be done only if the equation has one single variable. It means you only see the variable once. The y is in once. Okay, so if you see it once, you can apply function machines. Otherwise, it's going to be difficult, and even so, other method of solving equations tells you that the best way to start is just by simplifying the expressions on each side of the equation the most you can. So I'm going to simplify this expression, minus 8y plus 12y. So I'm going to imagine again my number line. I'm going to put minus 8y here, and I'm going to add 12y. So my answer is going to be this number that is here, that in this case is positive, and what will be the answer? So if it's negative 8 and plus 12, the answer is going to be 4, right? Positive 4. So in this case, my equation is 4y plus 12 equals 20. Now I'm going to apply the function machine. How do you apply the function machine? The variable is going to be the input. So I'm going to put the input. My variable in this case is y. I'm going to put the input, and my variable has some operations to get the output. In this case, our output is 20. So I can put here input y, and 2y I'm going to multiply times 4. And then after I multiply times 4, when I multiply times 4, I did this part. And then after I multiply times 4, I'm going to add 12. So when I multiply by 12, it means that I did all this part. And the output is going to be 20. Okay? Now, to solve the equation using function machines, what I just need to do is to apply inverse operations. So I'm going from the output to the input, applying inverse operations. So what I'm going to do is 20, and I have to take 20 and subtract 12. 20 subtracted 12 is going to be 8. And then I have to divide by 4. So the answer is 8 divided by 4. Observe that I'm not putting 4 divided by 8 because this is the operation. 8 divided by 4. So 8 divided by 4 is going to be 2. So y is going to be 2, the answer. Now, let's say sometimes some people don't like to do function machines because they already understand the method to solve equations that usually you see it like in higher levels, like 8th grade or 7th grade. But sometimes if you want to feel how to do it, like using the other method that is just adding or subtracting on each side of the equality, actually what we're doing is function machines. Why? Why? Because when you work out with function machines, when you identify the operations you apply to y, you can apply inverse operations to the equation. Observe. 4y plus 12 equals 20. Okay? For example, something that you can imagine here is that, for example, here you have y, you multiply it by 4, you have 4y, then you multiply by 12, you have 4y plus 12 is 20, right? So if I go backwards, I'm getting this term and then this term. So just for you to know, I can say, okay, so if I apply the inverse operation of adding, that is subtraction, I can observe that 4y is going to be equals to 20 minus 12. This is what I'm doing here, applying the inverse operation to read off the y, to find out y. And after I got 20 minus 12, that is going to be 8, 4y equals 8. So now I'm going to do the inverse operation of 4y to get y, that is divided by 4. So divided by 4 is going to be 8 over 4, that is going to be 2. This is the other way. Some people prefer to show that I'm applying the inverse operation each time, like subtracting 12 here, subtracting 12 here. If I subtract 12 on one side of the equation, I must subtract it on the other side of the equation. Then I have here 4, I divide by 4, divide by 4. If I divide on one side of the equation, I must divide on the other side of the equation. But if you observe, the three forms are exactly the same. The three forms are going to give you the answer. The three forms are going to show you how to reach our problem. Now, what do we construct function machines? Because in the first stages of learning, when you're learning to solve equations, it's important that you identify that the variable, you're doing something to the variable to get an answer. So what you're doing, in the case of our problem, what you're doing is operating, multiplying times 4, and then adding 12 to get 20. So this is why we usually start by constructing the function machine to understand what we're doing to the variable so we can apply the inverse operations. Okay, this is how you can apply function machines. Function machines. Okie dokie. And finally, okay, and that's it. I think that I just did a review of algebra. It takes me half an hour to work out on this review of algebra. And if you notice about this review of algebra, we also practice how to operate integers. Because, for example, in this case, in which we operate 12y minus 8y plus 12y, we operate integers. In this case, when we operate 16y minus 30y, you operate integers. And in this case, when you did minus 21x minus 72x, you use integers. So we also work out on integers. Okay, people that are online, I would like to know if you have more questions. Here the student tells me 4b. What happened with 4b? In here, look at that, it says h over 9, right? Plus 12 equals negative 8. So what is the operation that represents with a fraction? Division. So it means that I have to take h and divide it 9. Okay? H and divided 9. So this is like, if you're going to start the function machine, your function machine should start by telling you divided by 9. This will be when you work on 4b. Mr. Juan Diego, I think that I answered your question. Now, so I'd like to know if there's any other question before we finish today's session. This is a short session of half an hour, but it's just a review of how you can work with algebra and how you can see the process of operations. Algebraic expression, which one? When you mean algebraic expression means simplify the algebraic expression? Or you mean finding the algebraic expression? Because there's a difference. This is an algebraic expression, but this is simplifying the algebraic expression. And converting from algebra is this one. So I don't know what you mean when you say algebraic expression. I already did 2 out of 7. So I think that it was clear. So you can work out on the others. I think you can work on the others. We already talked about that. If I say the product means times of 3 times a number, so it means 3n, and 65, so it means 3 times n times 65. In this case, we need to multiply 3 and 65. If it said 6 more than half a number, so it means a divided by 2 because it's half a number, plus 6 because it says more than. When it says more than, we put at the end the term a, the term that is at the end, it's the one that goes first. I mean, this one goes first. And then you put the 6. Just remember, this is because it says more than, or less than. In less than is the same thing. Okay, everybody, I don't know if there's any other question that we can answer before we leave this session. I just wanted to take a few minutes to work out on algebra. In any case, you need anything to know about algebra, and be prepared for any exam that you have in the future. Okay, I don't see more comments, so I think that I'm going to stop the live session for today. Thank you for being here. Half an hour of working, half an hour of reviewing some ideas of algebra, and remember also a little bit of things about integers. Remember to work out on these type of situations. Remember of reading a lot, of checking a lot, and I'll see you in the next video. Bye bye, everybody. Have a nice day. Enjoy it. I hope that it helps you to understand more about algebra. See you in the next video. Bye bye. Bye bye.